Hi, Jono. I hope you've had a good tournament. We've missed you in class, so we're looking forward to having you back with us on Monday. I wanted to let you know a couple things that we've done in class. So here's an example of how we started class today. This is a photocopy of what is in the textbook, but I think it's easier to look at this way. So what we're doing is we're really trying to figure out like how much space this one section takes up, and then to say if we use that again, and if we used it, oh sorry, that's a little bit short, I think. It needs to be a little bit longer. And we're really trying this. You've done this with us, of course, with fraction strips and everything else. And so then we can see that we have fourths here. We have this section, 1, 2, 3, fourths. So that we know this is section that's shaded in as 1 out of 4. We've spent a lot of time talking about that this 4 is talking that there are 4 equal parts here. And this 1 is talking about the one section that's been shaded in. I picked this problem for you to see because a lot of people initially thought that this was a third, but then when we saw this other third was done here, that the third went over the goal mark, so we knew that that was not a third. So some of the other things we've been trying instead to do are to take a section that's shaded and break it into smaller regions. So we took this and broke this into halves, and then found that this took about here and that took about there. So which was really nice about this was that by breaking it into pieces, we ended up getting 2 out of a total of 1, 2, 3, 4, 5, or 3/5. Oh, I'm sorry, not 3/5, 2/5 were shaded. Okay, so 2/5 were shaded. Let me just write that again in a darker color for you. So 2/5. So now in this other video here, this other example here, and it's nice because these lines match up. So we know that these all would match up also. So these are fifths also, but this time we have 1, 2, 3, 4 of them shaded of the 5. So we know it's 4 out of 5 here. This last one we did the same sort of thing. And I would let you try this one on your own. Is that just looking at this, so we said that this is about the width of a pinky or whatever works for you, and then we just went through. And we did talk about that some people might get tenths, some people might get twelfths, and that's totally fine. The way that we've done it here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So in this case it could be 11/12, but depending upon how you measure it, it might turn out to be 9/10 instead, and that's fine. What was also on the last screen was that they had a goal, and they were talking about finding a certain fraction of a goal. So we've seen this with the fundraising thermometers that we've seen, so I'm just going to break this into fifths and say if I find that this whole thing is 200, that 4/5 of it, I first want to find out how much each section is worth. And because there are 5 sections, I can divide the 200 by 5 to get to 40. That means each one of these is 40. Because they're all the same amount of space, they're all going to be worth 40, which is so fantastic about fractions. Then what I can do is I can use this same idea here to say, now if 4 out of 5, so I want to take these here, and so we know that 4 groups of 40 would be 160. So you could say it's $160. Other people thought about it instead a little differently and said, well, I know it's everything of the 200 except for that, so they would take 200 minus 40. However you want to do this is fine. It's just that no matter the route we take, we're going to get to $160. The last part was that if they did, say, fundraise $80 of 200, what fraction did they raise money of? And we keep saying that the denominator is where our total is, or the number of parts, and the numerator is what they have. And so in this case, it's 80 out of 200. And we've talked about that we can have all these equivalent or equal fractions, and there's another video on that tonight for the weekend's homework. But you can have lots and lots and lots of ways to break this apart. So some people might divide them both by the numerator and denominator by 10 first, and then they might divide the numerator and denominator by 2, and they may do that again by 2 and get to 2/5. Other people may divide by 5, and they would get 16/40. They might divide by 2 here and get to 8/20. They might divide by 4 and get to, 2/5. Again, lots of ways to get to the answer. The only thing that really matters is that you can get to the right place regardless of the route you take. The only other thing that we spent some time talking about is if we go over our goal. So say that this is our goal here, and say a group of people have raised this, 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 and this. We said if they just raised up to here, that we know that that would be all of their goal, and that's in 1, 2, 3, 4, 5. So we know it's 5/5. But because there's another 5th here, we end up getting 6/5, because there are 6 parts of the same, 6 of those same 6 of those 5ths, which is more than a whole. And we're just feeling like that's okay because it's more than what they wanted to originally get. So Jono, if you need anything, just post something or email. But otherwise, we'll be excited to have you back in class with us on Monday, and hopefully this is helpful in being caught up. And we are going to have a quiz on something like what was on screen 1, where you are figuring out what the how much of it is, how much is shaded, what the fraction it is that is covered. Okay, have a great weekend, and I'll see you soon.